which usually consists of a pair of a label and a value. And finally, extractor is a tool to generate an annotation automatically. Okay, so this is what we're going to be using, and I'm going to quickly go into the second demo. And the reason I'm doing this demo now is because we're going to be launching some web crawling, and I'm going to finish the presentation while this thing is crawling here. So what you're seeing here is the annotator for Clam, which is a tool for editing and annotating multimedia data. And what I'm going to be doing is I'm going to define a new project. Let's call it this. Once I create a new project, I go into this screen in which I can add extractors. Okay, so extractors, automatic things that annotate this piece of data that I'm going to be adding. So, for instance, I can add an extractor which is called chords, and I'm going to just, this is a standalone piece of code developed in Python, and I add it to my project. And I'm going to add this other one, which is the semantic web. Pretty nice. Okay, here it is. Okay, so I just added a couple of extractors, which actually what they do is they define a description schema. This is, you're visualizing here an XML schema, where you have different levels of description of a given thing. In this case, it's a song. But actually, we don't even have the song. It's just an abstract song. But we have things like artist, album, the chord, because I added the extractor for the chord. We have things at every different, many different levels. We even have energy for every audio frame. But we only have the schema. We only have the definition. Actually, we need to add a song. Let me grab something like an MP3 file. Okay. It's not finding anything because I don't have anything. Actually, I'm seeing that there's some resolution might not be the best. But anyway, now I'm going to launch the computation of the descriptors. And in the meantime, I'm going to be switching to the presentation. But what's happening right now is that these two descriptors that I added, one which is really low-level signal stuff, which is core analysis, is analyzing, is doing the FFT analysis, and the other one, which is a semantic web, the extractor, which is actually launching a crawler out on the web. Hopefully, I was seeing we had problems with the connections, but hopefully it will get somewhere, and it's going to be bringing us back data about this particular song that is available on the web. Okay, so let's leave this here while it's finishing. I'll actually finish up my presentation, and hopefully at the end we'll all be happily looking at some descriptor results. So the annotator, it's a flexible GUI for annotating and editing multi-level audio music description. It's so flexible that actually the GUI configures itself to whatever the XML description is. So if you have the XML description that's telling it that you have chords, it will instantiate a particular widget which can deal with that particular data, and so on. We can do that, again, using XML and two kinds of XML files. The annotation schema, which is what I was showing you in a graphical way before, which describes number, type, range of descriptors, and then the descriptor pool, which is the actual file that contains the actual values for those descriptors. Now the cool thing is that those two things are uncoupled. I mean, they talk to each other, of course, but descriptors can be anything. It's a standalone application. It's a script that is somewhere, and the annotation schema is just giving us the form of that metadata. So the way we combine different descriptors and extractors is through the aggregation, and what the aggregator does is extracts subsets of descriptors and it combines them together into a single schema file, and we can do that through also two different concepts, what we call the sources, which defines the extractors and the descriptors pool, and the map, which is basically the mapping between the original descriptors in every single one of the extractors and the aggregated whole thing. So finally, just briefly going to mention what's happening with the web identification extractor. That's one of the extractors that I added to my project, and it's right now crawling the web looking for information about that MP3 file. So it's based on some existing library that's called GNAT, which was developed and presented a few months ago only. What this library does is uses audio fingerprinting, so basically some signal related data in order to fingerprint any MP3 file or any audio file and identifies songs on MusicBrainz. MusicBrainz is this open database of songs that is available, and it has a very nice RESTful API that you can use. Okay, so what this library does is identify the song and then outputs RDF statements which link your local file to a bunch of external resources. So what we do is we take those RDF files, we send our crawler, and we start extracting information from open-linked web datasets. So we get the identification, we get the RDF statements, we launch a crawler, and we have it crawl through different open-linked web datasets in order to extract descriptors, which can be anything. It can be descriptors of related to information on the song, user ratings, opinions, whatever. And actually, I had this slide just because I realized that that was one of the key words of the conference, especially after seeing the keynote this morning and the workshop on the first day. And I said, hey, this is cool. Open link data web, which is something that we're using here. And I don't know if, I guess that more or less everybody is aware of this W3C project, which is really interesting. At the current moment, or at least a month ago, it had 4.5 billion RDF triples interlinked by around 180 million RDF links, which sounds like a lot, but honestly, I mean, for instance, for music, you really have to pick your song in order to get interesting information. So we need a lot more of those open link data sets in order to have this working for like any kind of song or any movie or whatever. So hopefully I can just now go back to my application, which launched the 2 descriptors, and I can reload them. And actually that's where, okay, there it is. Oh yeah. Oops, is that doing weird things? So, yeah, there's some resolution stuff. Okay, so this is, this is what I got from the web-based extractor, the semantic web extractor. So starting from a simple MP3 file, I didn't have anything, I didn't even use the ID3 tags. I just sent some small information on the actual file to a service, and from there on I started crawling the web and I started finding things about this weird song, an artist that I don't really know. It's called Talking Pure, and the album is Hausarbeit. It's track number 3, title is Mud, the day that it was released. I get a bunch of song list URIs. These are URIs to the songs in the given album. I get pictures that are related to this particular song. I get tags that I found on the web from different sets, one from Jamendo, the other one for Semantic Web. I didn't get any tag from MusicBrainz because they didn't find it. I get an album description. I even get a review. There's absolutely everything done right in this album, so it looks like something you might want to listen to. The genre tag, and actually this is pretty fun because every time that I run it, I get different things because depending on what services and depending on the network, there is a timeout period. So whatever it finds, that's what you get here. You can get the artist's homepage. You get all of that. Now, What I also get, because this is the song level description,